Practice problem on Freefall. A girl standing on a bridge throws a ball upwards at 15 meters per second. If the ball lands in the water 4.5 seconds later, how high is the bridge above the water? First, let's take a look at the event. So here we have the girl on the bridge. She throws the tennis ball directly upwards, and then it lands into the water below 4.5 seconds later. Let's see what our given information is. Looking at the problem again, we see the initial velocity is 15 meters per second. The time in air is 4.5 seconds. And there's one other piece of given information, and that's the acceleration due to gravity, which would be negative 9.8 meters per second squared. So again, we can see the ball leaves her hand at 15 meters per second, which is the initial velocity. It's going to take 4.5 seconds to go from her hand into the water. The acceleration rate is negative 9.8 meters per second squared. And we're looking for the height of the bridge. Press pause and see if you can figure out the relationship between the given information and the height of the bridge that we're looking for on your own. Again, looking at the given information, we see the initial velocity is positive, that she throw it up into the air. Time is 4.5 seconds. Acceleration is negative, which is downward. And we're looking for the height of the bridge. I suspect this will be a negative distance because it's going to land below where it started from bridge height. So the relationship here between these, if we use our delta x equals VIT plus 1/2 AT squared, this will allow us to solve for that distance. Take a moment and put in your numbers and see if you can get a mathematical answer for the height. So putting in that given information, I get an answer of negative 31.73 meters. Again, all this negative sign means is that it fell below the top of the bridge level where she threw it. So that means the bridge height is 31.73 meters. So let's ask one more question. What is the velocity of the ball upon impact with the water? See if you can take a moment and use the given information to determine the velocity of the ball. So if we use the definition of acceleration, which is the change in velocity over time, which just means a final velocity minus an initial velocity. So here this would be negative 9.8 meters per second squared. VI would be 15 meters per second. If we accelerate at that rate for 4.5 seconds, we can determine the ball's velocity at that time. Okay, we can see the acceleration is negative 9.8 meters per second squared. We're looking for that final velocity when it hits the water. She did throw it upwards at 15 meters per second, and it took 4.5 seconds to hit the water. So solving that out gives us a final velocity of negative 29.10 meters per second. Again, the negative sign just means the ball is going downwards when it hits the water. Thank you for watching, and see you in class.